Dear participants, we are going to start the session. Today is the third day of this international workshop on digital image processing. And today we have one of the great scholars, Dr. Subhash Chavare sir. And today he is going to talk about Introduction to Digital Image Processing Lecture 3. And he will focus on raster data structures, header of the data, trailer files, and etc. Before going to start the session, first of all, on behalf of Devruk Shikshak Prasarak Mandals, Atle Sapre Pitre College Devruk, and all the collaborating institutions, I welcome Honorable Vice President of Devruk Shikshak Prasarak Mandal, माननीय श्री कृष्ण कुमार जी भोसले सर. Today's speaker Dr. Subhash Chavare from Sangli and all the participants. And I request Dr. Bharti Satpute Madam, who is my teacher, to introduce today's speaker. Madam, please, please.
Good afternoon, one and all. Myself, Dr. Bharti Shinde. Today, ASC College Devruk organized a workshop on digital mapping image processing. Today, I am here to introduce eminent guest speaker on the session, Dr. Subhash Chavare sir, Assistant Professor from Kranti Agrani GD Bapu Lad College, Kundal. He has completed his MA in from Shivaji University, Kolhapur, specializing in socio-economic development of Kolhapur city. He is completed MTech 2 times. First one, geomorphological mapping, Bharatidasan University, Tiruchirappalli. Second one, integrated approach of remote sensing and GIS from Maharashtra Remote Sensing Application Center. He also completed his PhD in watershed management of Erala River. He has 9-year teaching as well as research experience. He delivered about 35 invited lectures, also has 23 papers published. He presented 30 papers and participated in more than 47 seminars and workshops. We are privileged to have such an eminent personality to enlighten us. So now I request to Dr. Subhash Chavare sir to shed a light on raster data structure. Subhash Chavare sir. Thank you so much, sir.
Thank you, madam. Subhash sir, very good afternoon to all of you. To thank Sir and Devruk Shikshan Prasarak Mandal for me opportunity to share my thought on the raster data structure, header file data, Taylor files, raster data compression types. I think on the first inauguration purposes, invited Dr. K. Kumar sir. He is my mentor and he is my teacher from the Bharatidasan University. On Thursday, delivered by Dr. K. My teacher. I am also Bharatidasan. This is the third lecture going to deliver by the Bharatidasan. Thankful to all the participants and Devruk Shikshan Prasarak Mandal for the giving nice opportunity to share my thoughts. Madam just in my introduction told that eminent scholar. I am not that scholar, but I am trying my best level for the raster data structure and all the things. I think in the big topic, image processing and image analysis. For that purpose, now we can use various softwares. But before the software's invention, we are using the as a raster data, aerial photographs, then trigonometry, then we are overlapping, we are making 3D of that aerial photographs, and we are analyzing that features. After the invention of the satellite images, we are using satellite images for the remote sensing purpose, for the GIS purpose. Next one is geographic data. Means when we are doing research, doing work, or working in the GIS field, in the IRDAS field, or in the remote sensing fields, first things deals with the geographic data. This means geographic data, basically two types. The spatial data represents like location, size, and shape of objects on the planet Earth, such as a building, lake, like mountains. Means spatial data deals with the location, size, and shape of any objects. You can see in the image, we can say the point data, line data, polygon data, and this all the point, line, polygon is called, we can call the vector data. Because when we are dealing in the GIS, there are two main types of data. One is raster and one is vector. We can see in further slides, but before that, geographic data is categorized into two categories. That is spatial data with reference to space. That is location, size, shape of object on the earth. Another one is attribute data. Data about data, we can call it data about data, means any shape, any size, any location. Behind that, we can attribute data, means non-locational information related to that spatial data. Data which includes the non-locational data. We can say the name of location, size of location, shape of location. You can say the terrestrial boundary. You can the stream, river name, then polygon, area of that area. Attribute data is data about that spatial data, location, which is considered as a tabulated data about that data. Next one means, as I told you earlier, that vector data and raster data. जो दो फॉर्म्स है, दो टाइप्स है, वेक्टर डेटा और रास्टर डेटा. We can say the point, line, and polygon is in the called vector data. In the same raster data, we can say the pixel. Yes, pixel is a picture element. We can say that is picture element. Smallest size of that image we can call as a pixel. When we are zoom in that particular area, we reach up to the pixel size of that. We can reach up to that pixel size of that the image. That we can call as a pixel. In raster data, point also represented like same, is only single entity, xy coordinates. Here in vector data also we can call a single point or single dot, we can call as a point data. Line means two joining points, line entity. And polygon is a loop of that point entity. When when only loop is complete, that we can call as a polygon of that area. In the raster files, we can save that as a xy coordinates, that is point data, and then 2 point connecting each xy coordinates called as a raster data, and polygon is bulk of that pixels that we can call as a raster data. These are some of the basic types of raster and vector data. Now in this lectures we are going to deal with the only raster data. We are not image processing is done on the raster images. We can take as aerial photograph, we can take satellite image, we can take the scanned image also, we can convert. When we are scanning, suppose we are using one topo sheet of that our area, we are scanning that topo sheet and we are opening that in ArcGIS or in the image processing software. Basically we are using IRDAS imaging software, and for the GIS purpose commercial software we are using ArcGIS, QGIS also available. These are the two most widely used softwares in that GIS and remote sensing field. When we are using that scanned image, our scanned photograph also, these are also raster image, because when we are zooming that image, we can see the pixels of that image or that photographs. In the raster data set, we are using aerial photograph, we are using scanned image, scanned topo sheet, and an image taken by the satellite. All these image taken by satellites. We know about the image, satellite images. Satellites radiating the energy and then capturing the back energy, radiated back energy, and storing in the sensor and processing the satellite images, and each and every pixel having some specific value that we can call as a pixel value or digital number of that pixel. And we are processing. Suppose we are using the Google Earth image, screenshot image. We cannot process for that image for the land use land cover analysis for the another purpose, because that scanned image is not having that screenshot image or scanned image is not having digital number for that pixel. When we are processing the satellite data, this processing done on the basis of that specific digital number of that pixel. Means every reflection, every parameters, every features, every landform features having the specific pixel and specific pixel value that we call the digital number. We are processing on that. Very common things. We are processing the raster images, means we are not only processing, but process done on that lookup table. We can use histogram. You can see the pixel value. If you are opening the histogram, opening the pixel value, then you can see that each and every pixel having some specific value 0 to 256 in the grayscale. And we are processing on that particular. And reflection, one thing is that reflection means if we are taking vegetations, green vegetations having different digital number, then dense forest having different vegetation indices and vegetation digital number, then very old tree having different number, then crop to crop, when we are using the land cover classification, crop to crop we are having different digital number. According to that we can identify, we can distinguish between the crops. In the cropping growing season we can distinguish the crops. Then we come to raster data structures. In this lecture or in this international workshop, we are going to deal only the raster data set. The raster data structures. What is mean the raster? Raster is an array of cells, means group of cells, where each cell has a value representing the specific portion of the object or feature. Means only, each pixel having specific value, specific portion of the object, specific features. Means if we are taking the river also having so much pixels in the images. Means we can see the turbid water having different BN value, specific number, value numbers, then clean water having different number, hot water having different number, cool water having different numbers. In the water also we can distinguish between both hot water, cold water, turbid water, clean water, polluted water. We can distinguish between these type of water or pattern of water because of in each cell of value representing the specific portion. Means this cell is representing specific portion, that cell is having specific digital number of that features, reflected value of that features in each cell. Then point may be represented by single cell. As I told earlier, that point is a single cell of that object. We can see in the presentation only square box, that's XY coordinate square box, is called a cell. Point is only considered by represented by a single cell. Line is a sequence of neighboring cell. Means we cannot take line from pixel from first and then last one. Is having some neighboring adjoining cells. That only we can call the line features. Means I have already told that in the vector, starting point, starting node, ending node. In the raster cell, one starting cell, another is ending cell, we can say. And neighboring cells, it is required neighboring cells, because it's not having touch in between, means there are separate 2-point cells. We can call it a 2-point cell. जितना अपन क्या म्हणू शकतो, वहां पे क्या बोल सकते हैं हम कि दो अलग अलग पिक्सल है तो दो अलग अलग पॉइंट आएंगे. अगर यहां से नॉर्थ का एक पॉइंट लिया, साउथ का एक लिया, बिटवीन ज्वाइन नहीं है, वी कैन नॉट से दैट इज लाइन एंटिटी और लाइन बाय सीक्वेंस. because these two pixels mean two different pixels means these are 2 point pixels in a single cell. Polygon is collection of contiguous cells. As I told earlier, polygons having the loop or neighboring cells we can call as a point, line and polygon in the raster data set. Same as in the vector also, single point, then a starting and ending node we can call as a line, then a loop of the point we can call it as a polygon. And vector processing techniques are different and raster processing are different. In between, we can use different software, different technique also for the it's arranged in a row and columns. We can see the cell are arranged in a row and columns. That is Cartesian matrix. We can call this technique as a Cartesian matrix. The rows of the matrix are parallel to the x-axis. We can see the rows are in the purple color. We can see in the row highlighted as the x coordinate and x-axis and Cartesian plane, and column to the y-axis. Each cell has a unique row and column address. Each cell having unique column, unique number. In the Hilda's imaging language or in the image processing language, we can call as a pixel number or digital value of that. As I told earlier that
it's not moving, it is stable.
As I told earlier that मैंने आपको पहले बताया कि इमेज के पीछे जो डिजिटल नंबर है, पीछे मीन्स when we are zooming in that we are seeing the lookup table of that image, we are seeing the histogram. If digital number is absent, we cannot do processing on that images, because our processing is based on that digital number. On that digital number, we can identify the features. The same digital number होगा तो same feature है, मतलब डीप वाटर का जो पिक्सल नंबर यहाँ पे आएगा वो डिजिटल नंबर कहाँ भी आएगा वहाँ पे वही आएगा. We can work on that only. Then raster data structures in that in topic header file, then data types and tailors. Header में क्या आता है तो dimension and spatial resolution आता है. जो we can see the spatial resolution of the images 30 meter resolution. Now we can get the 0.5 meter resolution of the word view data. We can get the satellites in 0.5 meter resolution data. Means we are getting higher the resolution, we are getting more specific information regarding the surface or region on. If you are taking the our resource at image, we can cover 23 kilometer area we can cover in that. Then spatial resolution 30 meter resolution, we get higher resolution we are getting data. In that data we can get the more specific, more detailed objects or features from the earth surface. मुझे क्या है जितना हम हायर रिजोल्यूशन लेंगे उसमें हमको ज्यादा डिटेल्स इमेज में मिलेंगे. जे काय की जेवढे आपल्याला हायर रिझोल्यूशन मिळेल, आता सध्या 0.5 मीटर पेक्षा बी जास्तीत जास्त रिझोल्यूशन मिळते, त्या रिझोल्यूशन मध्ये आपल्याला एकदम डिटेल्स मध्ये. आता जरी आपण गुगल अर्थ ओपन करून बघितलं, इफ वी कॅन यूज गुगल अर्थ or Google Maps, we can see the specific features, we can see our house also, we can see road also. Up to that meter the satellites are scanning and we can use that data for our application purposes. Then projection and coordinates. In the header file we can see the projection and coordinates. Means satellite having some projections, means satellite settled by some projection, we can use this projection for our purpose. Means if we are overlapping the data layers, data files in the same window, if the projections are different, we cannot overlap that and we cannot process. उसमें एरर आ जाएंगे कि if your projection is not same, we can do processing. Same like errors will arise. ऐसे errors आएंगे कि उसके लिए ArcGIS में होगा, IRDAS में होगा. In IRDAS we can process, but in ArcGIS there is no possible without the projection. we get error and it is not possible to process the data in different projection system. We have to then for that purpose we have to reproject the data, and we have to use the same projection, same geographic coordinate system, projected coordinate system, and then only we can use the data for processing. Then coordinates that we have know about the coordinates, XY coordinates, I mean longitude and latitudes regarding the data. Now we are using the satellite data is already projected. We need not to reproject the data, because if we are downloading the satellite image from the Earth Explorer, EVGS, or from the Bhuvan 3D, or otherwise we are getting the data from the NRC, that data is projected. There is no need to reproject the data for our purpose. We are not going to reproject, or we are getting directly projected data. Just only we have these information called as hidden information, and another information regarding that satellite image, when it was taken, which satellite, which sensor used for that purpose, then date, season. That information comes under the header file or header information of the raster data. Then data type. In the data types, ASCII data type, binary 1 bits, integer 8 bit, floating point in 4 bytes, and single band, multi-band structures also. .img, TIFF format, IMG format, then JPG format. In last, Taylor files are color lookup table and statistics. Means lookup table. In next slide, I will inform you. I will explain the what is lookup table and that color of that image or color of that streams, lookup table of that area, and statistics regarding that image. Here also we can see the header also. Properties of the raster file or raster data, such as cell size, number of rows and columns, and coordinates of the origin of the raster. In image, you can see the image space, column XY coordinates, column 8, rows 8. This we can call this row number of rows and columns. Then coordinates, grid location, grid point, XY coordinates, cell size, list of cell values. These are information called as the header information. Means properties of the raster data, properties of the raster file is called the header information. जो raster data की जो property है उसको हम हेडर फाइल कहते हैं. क्यों हेडर इंफॉर्मेशन कहते हैं? सेम एज टोपोशीट की हेडर इंफॉर्मेशन होती है, एरियल फोटोग्राफ की हेडर इंफॉर्मेशन होती है, जेपीजी हम स्कैन करेंगे टोपोशीट उसकी आती है. टोपोशीट कब सर्वे किया है, नॉर्थ है उसका लैटिट्यूड लॉन्गिट्यूड है, उसका एरिया कितना है, 1:50,000 पर स्केल है, 1:64 है, 1 इंच का है या कौन सा है. नाउ वी कैन से गेट 1:10,000. These are called as that header information. Same as raster. For raster file, raster data, we can call cell size कितना है, number of rows and number of columns कितने हैं, उसका coordinate system क्या है, उसका projection क्या है. हमको जो डेटा अभी रास्टर का मिलता है, रास्टर क्लास इमेज का मिलता है, जो भी डाउनलोडेड हो या कहाँ से सैटेलाइट एजेंसी से एक्वायर किया हो, ऑब्टेन किया हो, हमको प्रोजेक्शन करने की जरूरत नहीं पड़ती है. उसको जो हमने बोला है, मांगा है उनको, वो क्या व्हाट वी हैव रिक्वेस्टेड टू distribution agency, they are giving to us. उसमें reprojection की जरूरत नहीं, we have to process on that only. That reprojection work और coordinates work जो है, वो जो एजेंसी है, एजेंसी के बाद डेटा एक्वायर होने के बाद सैटेलाइट से, सेंसर से डेटा एक्वायर होने के बाद वो प्रिपेयर करते हैं. वो जो उसमें से एरर्स होते हैं, बाद में लेक्चर्स हो जाएंगे उसके, रेडियोमेट्रिक एरर्स है, स्पेशल यूटिलाइजेशन में एरर्स है, देन क्लाउड कवर का एरर है, वो कैसे रिमूव करेंगे, क्या बाद में जो आपका वर्कशॉप आगे बढ़ते जाएगा, वो जो डिटेल्स होंगे इमेज के बारे में वो आगे आगे चलते जाएंगे. लेकिन स्टार्टिंग लेक्चर्स में हम क्या देख रहे हैं कि व्हाट इज रास्टर डेटा, हाउ वी आर गेटिंग दैट, इन व्हाट फॉर्मेट वी आर गेटिंग दैट, एंड देन what are the information regarding the raster data, such as the, now we are seeing that is header information. Then Taylor, I told lookup table. A lookup table is a list of values that are stored in the memory of the microcomputer, which can be accessed using the read table command. Lookup table is in image, you can see the image as well as digital number of that, and inside we can say the type or type of data, count of that data, area code. Likewise, this data regarding that image stored in the tabular format we can call as a lookup table of that particular satellite image. If you are using imagine software, you can say these statistics using the lookup table command. You can access that using read table command, and you can see what is behind that satellite image. Lookup table is a digital file that transforms the color and tone of that image. जो इसका टोन है, कलर है इमेज का, वो डिजिटल फाइल में ट्रांसफर करने के लिए हम लुकअप टेबल को लिखते हैं. तो ये स्टैटिस्टिक है, लुकअप टेबल है, इसके ऊपर ही सब कुछ काम चलता है. मैंने अभी बोला कि डिजिटल नंबर, जो डिजिटल नंबर सांगितला, ऑन दैट डिजिटल नंबर वी आर प्रोसेसिंग द डेटा. अप टू नाउ हमने जो देखा तो रास्टर, वेक्टर डेटा. फर्स्टली हमने देखा कि ज्योग्राफिक डेटा में क्या क्या आता है, बाद में उसमें वेक्टर डेटा, रास्टर डेटा, which we are using mostly in the GIS and remote sensing that we can call image processing. After that header and after that हमने देखा कि रास्टर डेटा मॉडल देखा, उसमें पिक्सल देखा, उसके बाद में जो स्ट्रक्चर में हेडर है, देन टेबल फाइल है, उसके बाद में रास्टर डेटा कॉम्प्रेशन. ये कॉम्प्रेशन जो है, कॉम्प्रेशन इज प्रोसेस ऑफ मेकिंग डेटा मोर कॉम्पैक्ट सो इट ऑक्युपाइज लेस डिस्क स्टोरेज स्पेस. जो डिस्क का स्पेस है, if we are using 2-3 satellite images at the same time, that having more than 1-2 GB data, the size of that file. If we are downloading Landsat 8 image of the one cell or one tiles of that image, it is having 900 MB data. मतलब हम जो एक भी टाइल्स डाउनलोड करेंगे, मतलब इसमें से USGS से और एक्सप्लोरर से हम एक भी टाइल्स डाउनलोड करेंगे तो हमको उसका साइज जो है, साइज मिलेगा 900 MB के आसपास, लगभग 1 GB के आसपास होगा. Of that data, if we are processing that type of bulk data, means it is required more space in your system, more space in your computer, laptop, whatever you are using for the processing. Then processing means your computer, your system need that much capacity to handle the data. For that, raster data compression is needed. Means we have to compress the data and reduce the size of that data to store, to process. Means compression is the process of making data more compact, so it occupies less disk storage on space. When we are using the data, it is required less storage, means we can handle it properly. The primary benefit of compressing raster data is reduction in file. Means what I have told now, that is reduction in file size. In the next 2-3 slides, I will explain how we can reducing that file or type of that files. This primary benefit of our compressing or compression type, compression requirement is we have to reduce the file size for the using purpose. Then transferring data from the server to an application. If we are working on a one computer, we have to transfer this data to another one, another agency, another person. It is difficult to transfer that much of bulk size. So if we are using data compression technique, in that raster data compression technique, we can transfer our data easily to the server, to the applicant, to the another user, to the end user. For that purpose, we are using the raster data compression. मतलब इसमें हम क्या करने वाले कि जो साइज है डेटा का उसको थोड़ा कम करना है. तो कम करते वक्त, कम करते समय, when we are reducing that size, there are two types मतलब two methods. डेटा क्वांटिटी और क्वालिटी जो कम नहीं होनी चाहिए, लूजलेस एंड लूजेस. यू कैन सी नेक्स्ट वन. हमको जो है डेटा साइज कम करना है, लेकिन जो क्वालिटी है वो मेंटेन रखना है. We have to reduce the size but maintain the quality of that data. आगे चल के मैं बताऊंगा. When we see the next slide, I will explain in that. The normal size of the raster data in sometimes we can see the normal size. Here I am giving, for example, normal size of 8-bit RGB image. That is being blue image. If we are getting 8-bit data, measuring the 10,000 into 10,000 is calculated in the pixel size in that area. 10,000 width, 10,000 height, multiplied into three samples using 1 byte data. You can see what is the number of bytes. And the size of that image is 300 MB. If we are using 10,000 height, 10,000 width of that RGB image in 3 samples, we are getting 300 MB of that or that image. म्हणजे इसमें कितना साइज मिलेगा 300 MB मिलेगा. 300 MB त्या इमेजची साईज होणार. म्हणजे आपण अशा एक इमेज झाली. पण when we are using our study area, our working area or our research point, research area जो है 2 इमेज में आएगा, 3 इमेज में आएगा. कभी कभी जो स्टेट लेवल करेंगे तो बहुत सारे इमेज आएंगे. when we are using the state wide, we have to collect, we have to use image. If one image is 300 MB means here we are using 10 images means 3000 MB data, more than 3 GB. That is main problem is processing of data. For that purpose we are compressing the data at the smaller size. Compression ratio, one of the basic thing is the compression, and what basis and what ratio we are going to compress that images. The larger size, the compression is image of size ratio of 20 as 1. It means target size is 5% of the normal size. This compression is expressed as a ratio of normal size to the target size, means output size. Here we are using the 20 as to 1 size of the above image. जितना है उसमें से हम 20 as to 1 लेंगे तो 15 MB तक हम उसको मिनिमाइज कर सकते हैं, रिड्यूस कर सकते हैं for the processing purpose, for the transforming purpose, for the using purpose. The compression is usually done by using the image file compression algorithm. That algorithm we are not going to develop. That algorithm is already developed by the software. इसमें हमको डेवलप नहीं कुछ करना है. हमको सैटेलाइट इमेज मिलेगा, उसको हम सिर्फ खाली कमांड देके ये करेंगे. उसमें हमको कुछ नहीं करने का है. तो जो algorithm डेवलप किया होता है वो सॉफ्टवेयर में डेवलप रहता है. We have to use only that tool and we are doing that. That encoding information for fewer bits than original uncompressed image. Then there are 2 types of image file compression algorithms. Basically we are using in the raster data compression, that are lossless compression and loosey compression. The basic difference between two is, इसमें जो डिफरेंस है लूजलेस कंप्रेशन में और लूजी कंप्रेशन में. लूजलेस कंप्रेशन में हम कुछ नहीं लूज करते. लूज मतलब कुछ नहीं खोते हम उसमें. म्हणजे की लूजलेस कॉम्प्रेशन आपण जर टेक्निक असेल त्यामध्ये आपल्या डेटामध्ये काही फरक पडत नाही. म्हणजे डेटा क्वालिटीमध्ये काही फरक पडत नाही. लूजी कॉम्प्रेशन मध्ये काय होतं की त्यातला काही पार्ट आपल्याकडून लूज होतो, त्याची क्वालिटी कमी होण्याची शक्यता असते किंवा होते. लूजलेस कॉम्प्रेशन में क्या होता है हम कुछ खोते नहीं उसमें. इमेज का क्वालिटी है एज इट इज रहेगा. ओनली वी आर गोइंग टू रिलीज द साइज ऑफ दैट इमेज. एंड इन द लूजी कॉम्प्रेशन में क्या होता है, लूजी में हम थोड़ा बहुत क्वालिटी डिटरेट हो सकता है, कम हो सकता है. इन लूजलेस कॉम्प्रेशन वी आर नॉट लूजिंग एनी डेटा or not losing quality of that images. But in loosey compression technique or loosey compression method, we are losing some of the points and getting the smaller size. This is the basic difference between the looseless compression and loosey compression. You can see looseless compression is a compression without any loss of data quality. As I told earlier, when we are using the looseless compression method, we are not losing any data quality. That algorithm is eliminating the redundant information while preserving the perfect copy of original uncompressed image. इसमें जो क्या होता है, जो हमको नहीं चाहिए, वो जो इंफॉर्मेशन इमेज के साथ है वो रिमूव हो जाती है कॉम्प्रेसिंग करते समय। इसलिए हम जो इंफॉर्मेशन हमारी क्वालिटी की है वो लूज नहीं करते। दिस इज डन बाय राइटिंग द डेटा इन मोर स्पेसिफिक वे। इसमें रिपीटेशन जो है, वी आर रिमूविंग द रिपीटेशन एंड रीराइटिंग द सैटेलाइट इमेज इन दैट प्रोसेस, removing all kind of repetition. We can see the buffer area or overlapping area. We can say in the aerial photograph we can see the overlapping of the same area double आया होता है। The same image also overlapping satellite का overlapping कुछ तो area होता है। So आपके माध्यम में overlapping area होता है, वो overlapping area है जो कम करने का है। क्या करते हैं, वो में साइज कम हो जाता है। We can see a numerical example for the looseless compression. Here is a numerical example, number of 7 gray pixels. We have 7 gray pixels, then we have to minimize that. Can be returned in shorter numbers requiring less bits like 128 का 1 है, then उसके बाद में जो लिखा है 128 लिखा है, उसमें बाद में 128 के बाद लिखा है -1 उसमें बाद में प्लस प्लस, ये जो है 1 पिक्सल कंसीडर करके उसके बाद में रिराइट करना है तो शॉर्ट करना है तो ऐसा लिखते हैं शॉर्ट में सैटेलाइट इमेज वी आर यूज that number repetition of that data, then we can get the data without losing any quality of data or important information. क्या लॉस ऑफ डेटा क्वालिटी, इसमें सम लॉस होता है डेटा क्वालिटी का। ये जो में देखा आपने कि 7 ग्रे पिक्सल जैसे क्या 126 -6 एंड रिजल्ट आफ्टर जो दिखेगा आपको, मतलब जो रिमेनिंग 6 है, रिमेनिंग 6 जो 128 के बाद में जो पिक्सल आएंगे वो 6 पिक्सल, 7 में से 6 पिक्सल है, 128 निकाला हमने और उसमें से -6 हटा कर दे, रिजल्ट आफ्टर डिकम्प्रेशन इज जो ऊपर दिया है 28 128 -6 हुआ तो क्या हुआ 127, 127 से -1 लिया 126 माइनस जो 111 न्यूमेरिकल एग्जांपल है। सेम जो अल्गोरिथम जो होता है वो सॉफ्टवेयर में ऐसे ही होता है, वैसे ही कुछ किया जाता है। There are two, what I told earlier, that there are two compression techniques. One is looseless. In that, 3 methods or 3 types: cell by cell encoding, run length encoding, then quadtree. In the low G compression, JPEG compression, and YAML SID, multi-resolution seamless image database. You can see one by one. आवाज आ रही है ना सर मेरी?
Yes, sir.
Yes, sir.
हाँ हाँ। Then cell by cell encoding, जो अभी चल रहा है कि इमेज प्रोसेसिंग, डिजिटल इमेज प्रोसेसिंग, इसमें हम ज़्यादा ऑफलाइन रहते ज़्यादा एक्सप्लेन भी कर पाते हैं, ज़्यादा बता भी पाते हैं। वी कैन सी, वी कैन एक्सप्लेन मोर, वी कैन शेयर मोर, we can do at immediate we can do the see the on limitation for the explanation. We can see the cell by cell encoding is example. This is minimally intensive method encodes a raster by creating record for each cell value by row and columns. इसमें देखेंगे तो सेल बाय सेल रो 1 में 5 नंबर का पिक्सल यूज किया हुआ है, मतलब उसमें हमारा फीचर है 2 नंबर का जो इन द नंबर इन द 4 to 6 नंबर जो है 4 ऐसा तो ब्लैक एंड व्हाइट इमेज में तो देखोगा कि कौन से में वैल्यू है, कौन से इसमें वैल्यू नहीं है। ऐसा करेंगे आप इसमें से सेल बाय सेल करते समय जिसमें वैल्यू नहीं है वो हम रिपीटेशन के लिए नहीं लेंगे, इसीलिए जो है तो डेटा साइज है तो कम होते जाएगा। साइज smaller size of that redundant encoding. In that method, data stored row by row basis instead of recording each individual cell. जो पहला मेथड देखा हमने सेल बाय सेल है उसमें तो बताया है, उसमें सेल बाय सेल एनकोडिंग, इनमें वो जो है दैट इज सेल बाय सेल एनकोडिंग में मेथड इज दैट नेम ऑफ मेथड दैट इज सेल बाय सेल means in this we are not going to take the individual value. Redundant encoding method use or groups the value by rows. You can see in the say take the this line of data A B B B C C C. You can see B कितने टाइम आया है, A 6 टाइम A, 4 टाइम 9 टाइम C, मतलब ग्रुपिंग किया है। सपोज हम लेंगे एग्जाम फॉर एग्जांपल लेंगे तो हमको हाइट निकालने का है, स्कूल हाइट निकालने का है तो सेम हाइट वाले सेम एज वाले जैसे हम ग्रुपिंग करते हैं सेम एज ग्रुप। स्कूल में बच्चे लोग होंगे तो इफ यू स्टूडेंट आर इन द क्लास वी आर ग्रुपिंग एज वाइज हाइट वाइज सेम लाइक हियर नॉट here only get by basis instead of each individual cell using we are grouping for example that after the figures the fourth thing and time is C that is data row by row basis. See the example first bank and in store as a 08 मतलब इसमें कुछ नहीं है, because this means that there are 8 cells and they are all zeros. इसमें डेटा ही नहीं है। पूरा satellite image we can get the full satellite image but some pixels are not having the digital numbers, or by error we are not having any number that we have to eliminate. In the second row value of 0 and 4. After this we have 3 consecutive cells 1 or 3. Last cell at row we are saying है जो भी group first row is blank 808. This means there are there is that in that. These are the redundant encoding. Then इसमें most common compression method apply to raster data. ये जो method है quadry method से we are using the most common method for the data encoding or data compression based on the successive reduction of homogeneous cells. जो है इसमें quadrant semi-quadrant ऐसा जाने का है. It recursively subdivides the raster image into quarters, then sub-quarters, and then reaches and all each cells on the quarter basis. On the quarter basis successive for homogeneous cells. Homogeneous is the same number. As I told you, grouping on the same number. Here we are using quadrants on the homogeneous cells. So we can one and you have to pixel four value 4 that's how much बोला सर हाँ हाँ say the example value 1 having 4 pixels, value 3 having 4 pixels, value 8 having 4 pixels. That is homogeneous group. In image 1, 3, 8. Another one having, in considering with the 10, that having 4 different values. One node 7, 13, 7, 10, 11, 31. We can group that 4. That is different cell or different values based on the successive reduction on the homogeneous. हमको रिडक्ट करते जाने का है मतलब डिडक्शन करते जाने का है ऑन द बेसिस ऑफ होमोजेनियस सेल्स सेम होंगे उसमें हमको क्वार्टर क्वार्टर बनाते सब क्वार्टर क्वाड्रेंट सब क्वाड्रेंट ऐसे बनाते जाएंगे तो वो इसमें से जो है साइज जो है रिड्यूस होते जाएगा सेम वैल्यू है उसका ग्रुपिंग हो जाएगा सेम नहीं है वैल्यू उसका अलग अलग तरीके से ग्रुपिंग हो जाएगा अलग वो वैल्यू स्पेसिफिक रहेगी लेकिन which are the values are same grouped automatically and separate value single number value that is separate and जो है एक का 8 का उसकी वजह से क्या नंबर same number digital number it means same any feature on the earth surface that is to one category and another one is the remaining category. That's why the image reduces automatically the size. That raster compression we have to reduce the data size for this specific purpose or for the our processing purpose. That is the main theme of the raster data compression. That was why we are compressing the data. For the purpose of use, for the purpose of transfer, we are compressing the data. In that, there are two methods for the compression. One is lossless, one is loosey. In the lossless compression techniques, we are not losing any data, any quality of data, but we are removing irrelevant information of that image, and we are getting the smaller size. In loosey technique or loosey compression method, we are reducing the size of the data, but losing some of the quality or some of the data in that method. And loosey compression. Most of the methods we are using looseless method. Loosey method is only for the JPEG and another one type purpose. But most common method is quadri method, most commonly used for the image compression. After that, we are using the run-less encoding method for the raster data compression. In loosey color is converted from RGB by CDCR. Luma component it representing Y, that is brightness, to chroma of that sensitive to the fine color details than fine brightness details. For the looking purpose or for the compressing the data, JPG data. In examples, you can see the loosey compression, how we can build example of JPG JPG compression. Left to the right, decreasing the quality setting results in 8x8 block generation of pixels. If we are using that logi compression techniques, we can lose some of the pixels, we can lose some of the quality. Here you can see the left side, you can see the finer the texture and finer the color, but you can see the right side having some blur pixels. Same like when we are using camera, when we are taking pictures, that if you want that, in general talking, we are transferring our photographs by WhatsApp directly, we can say it is not coming that much quality. Send by documents, we can say the send by document file format. हम जो WhatsApp में शेयर करेंगे तो उसमें हम क्या करते हैं, सीधा डायरेक्टली WhatsApp से भेज देंगे तो हम क्या बोलते हैं, उतना क्वालिटी ट्रांसफर नहीं होता है. मतलब जैसा निकला हुआ है फोटोग्राफ्स वैसा एज इट इज क्वालिटी ट्रांसफर नहीं होता है. फॉर दैट पर्पज व्हाट वी कैन यूज, that same photographs we can send by the document data type. That at that time we are getting the proper quality of that original photograph. When मध्ये काय फोटो दुसऱ्या त्यावेळेस जो सेंड केला इमेज सेंड केला तो लगेच जातो, लगेच डाउनलोड होतो, पण क्वालिटी थोडी ओरिजिनल फोटोपेक्षा कमी होते. पण तोच फोटो काढला शेअर केला किंवा पाठवला जास्त आहे. पण email other than that, other than e-processing, day to day upload करायचा and this tool get that, but that loosely method competent technique, we are losing our quality our photograph. That is there is in JPG in the JPG in this method is only for use for the JPG and that quality. Another one SID multi-resolution original for the joint system format larger raster image photo image compress quickly without मतलब इसमें क्या larger कॉम्प्रेशन आहे इनिशियल मध्ये, पण ह्या जास्त आता ही ऍडव्हान्स टेक्निक राष्ट्र कॉम्प्रेशन आहे पण त्या आहे यामध्ये जास्तीत जास्त जी लेस मेथड यूज करतात. म्हणजे वी आर मोस्ट ऑफ द टाइम वी आर युजिंग कॉमनली लूजलेस मेथड फॉर द raster data compression. We are not using loosey methods because if we are losing the data quality, how we can process on that data? For that purpose, we are using the looseless compression. In that most common that is quadri, and after that run length encoding we are using for the data compression, raster data compression. Thank you, sir. If anyone having any questions regarding this one?
Yeah, yes. Thank you very much, Chavare sir. There was some disturbance in between, and it was at the end of internet connectivity. You tried at your level very best, and I'm sure the concepts related to raster data structures might be clear at the end of participants. Dear participants, if you have any query or if you are interested to get some additional information related to raster data structures, please feel free to ask either through chat box or by unmuting yourself. Uh, the topic delivered by Dr. Chavare is very much technical and it requires 100% concentration to understand. And the topics which are being covered through this international workshop, uh, the main motive is to understand the basics, fundamentals which are related to digital image processing. So, if you have any queries, kindly please feel free to talk or ask through chat box. Yes, someone has raised hand. Chaure sir, on behalf of देवरुख शिक्षण प्रसारक मंडल्स Atle Sapre Pitre Autonomous College Devruk and all the collaborating institutions, I extend our sincere heartfelt thanks to you for sharing your valuable time and sharing your talk on the topic provided to you. I am sure the address delivered by you will be definitely helpful to all the participants. With this concluding remark, once again I extend to you. Thank you very much.
Thank you, sir.
Thank you, sir. Thank you.
Thanks for giving nice opportunity. In future also, I'm ready to
Definitely,
serve with.
we will be in collaboration. And
Thank
as I already told you that we will conduct online workshop on QGIS in Marathi language. In Marathi language.
Okay, okay. काही प्रॉब्लेम नाही सर, घेऊ आपण.
Okay, okay. Thank you.